Hello, dearest friends. Today we are going to talk about solving trig equations, but now we're getting intermediate. Oh man, look at us. Okay. We have an example here of 4 cosine squared x minus 3 equals 0 when x is between 0 and 2 pi. So when you solve trig equations, I want you to think of them like you'd solve something like 4x squared minus 3 equals 0. Remember when we did use substitution with exponentials and stuff, right? You want to think about this in terms of x's, but if you had x's with no trig functions, my goal would be to get x alone in this case. So I'm going to do the same thing here, but my goal is to get the entire trig function alone, right? To get the cosine x all by himself. We want to solve for cosine x. That's what our answer is going to be of the form. So in order to do this, you're going to want to isolate the cosine x. So we have 4 cosine squared x minus 3 equals 0. I'm just copying it because this guy's in the way. Okay, so I draw my line. I add a 3. I'm just slowly moving all the pieces away from the cosine of x. Divide both sides by 4. And I have cosine squared x equals 3 over 4. And remember, this is really... So I can square root both sides, and I would get the cosine of x equals plus or minus the square root of 3 over 4. Now, this is not in my table, right? The square root of 3 over 4 is not in my table. So let's try to rewrite it in a more familiar way, and maybe it'll look like something that's on the table once we redo it a little bit. So I would have plus or minus the square root of 3 over the square root of 4. I can rewrite this like that. And then, okay, I've got something good now. I've got the square root of 3 over 2. Okay, and that is certainly on my table. I see it right for cosine right here. Okay, so pi over 6. Cool. I'm thinking in the vein of pi over 6 now. All right. So rad 3 over 2 lives in the pi over 6 column. And I want to figure out this plus or minus nonsense right here. And how I would do that is I'm actually going to have 4 answers because I want the positive and negative values. So the values of x that will make cosine spit out rad 3 over 2 is, of course, pi over 6 in the first quadrant. And then if I rotate over to the second quadrant, well, let's think about it in terms of counting in increments of pi over 6, right? In the second quadrant, it'll be 1 more before 6 pi over 6. So over here, it'll be 5 pi over 6. And then in the third quadrant, okay, so these are where it's going to be positive, positive. In the third quadrant, oh wait, it's cosine. I'm so sorry. So in the first quadrant, it'll be positive. Up here, it'll be negative. So in the third quadrant, it will be 1 more than 6 pi over 6. It'll be 7 pi over 6 because I'm going back up to the x-axis, right, for the reference angle. And then in the fourth quadrant, it would be 11 pi over 6 because I'm going just, one increment back up to get to 12 pi over 6, okay? So I have 4 possible answer choices. I have x equals pi over 6, 5 pi over 6, 7 pi over 6, in which case cosine would be negative, and 11 pi over 6, in which case cosine would be positive. So we've got 7 pi over 6 and 11 pi over 6. Word up. All right. So for number 2, think about solving a question like this. All right. I've got 2x squared minus, there's no sign. X minus 3 equals 0. Okay. Just like we would want to isolate the x in a problem like this, I'm going to want to isolate the trig function of sine of x on the one on the left. Okay. So instead of factoring with x's, I'm going to factor with sines. Let's go ahead and do that. I've got 2 sine x, I'm going to have to do some math to figure out those numbers, times the sine of x. And then I'm looking for the factors of -3 times 2 that add up to -1. So that would be -3 and +1. Okay. So now I have my two factors that I'm going to set equal to 0. Okay. And now I just solve. 2 sine x minus 3. I'm going to add a 3, add a 3. 2 sine x equals 3. Divide both sides by 2. Sine of x equals 3 over 2. Let's consider that, okay? Think about a sine curve, just a plain old sine curve, right? It's sandwiched between 1 and -1. So any value that is above 1 or lower than -1 is not going to be in the range of a sine curve. So 3 over 2, aka 1.5, is greater than the range of the sine curve. It is out of range, and we are never going to see 3 over 2 in a plain old sine curve. So we would go ahead and reject this answer choice. But let's go up here and see if we can get another one. So I've got sine of x plus 1 equals 0. -1, -1. I have sine of x equals -1. Okay, so -1 is not going to be on my common trig ratios, but it is right on the unit circle. So I could do 3 pi over 2 and see that that is in fact where my y coordinate or my sine is -1. So I would say that x equals 3 pi over 2. And that would be my solution to that problem.